Hey everybody, today we're going to talk about a really fun topic and it's guardrails. So we're going to try to go over what are guardrails and how do they work and do they help us, for example, address privacy problems in our machine learning models. So guardrails is a really difficult term because as soon as somebody started using it, people started using it for everything. And today we're going to disambiguate and talk about what are different approaches to guardrails that are all covered under this blanket term guardrails. All right, you with me? Okay. The first thing we're going to talk about, or the first type of guardrail, is a software-based guardrail. So what that is essentially a way that we use software processing, so normal software, to do input and output between, let's say, an LLM, but it could be really any model that we would like to protect the input or the output or both. And often these software based use, let's say, basic ways in software we can either do exact match or near match prediction. So what this might mean is something like a particular Bloom filter style approach or other advanced memory architecture where we can say, here are the things we definitely don't want going into the LLM or other model, and here are the things we definitely don't want going out of the LLM to the user. And then if we find a match, we essentially do hard stop and sorry, we can't respond, or other type of canned response, right? So this means, that we can do it really fast. That's an advantage, right? With Bloom filters or other advanced memory architectures, we can find perfect or near matches quite quickly. But it's also, as you know, if you've ever had the beauty of working with such things or had the beauty of working with something like regex or something like this, it's also quite brittle, right? Nuance is lost. There's no nuance to these things. And so this was a presentation from Zhang, was able to go around copyrighted code restrictions. Here we're seeing some code that is copyrighted that Copilot was blocking and yet was able to get around it by just changing the variable names to French. Then easy to bypass the filter because different enough doesn't match these kind of brittle, fast, but in a little way hard-coded filters versus more nuanced attempts. So from a privacy point of view, this doesn't really scale. From a security point of view, there might be some interesting applications where you just want to say block curse words or something like this. By all means, if it's easy to define and there's a limited space, or if you just want to try out using software-based guardrails or filters, that's by all means something that's available. So that's our first type of guardrail. But of course, we've already seen this doesn't really address everything. So there's another type of guardrail. And this I would call external algorithmic guardrails. What does that mean? Well, they're external. That means they're not actually in the LLM or the main model that you're using to run inference. They're outside of it. And these models or these algorithms, they could be either, are there to specifically to give a classification or a binary decision, yes, no, is this content allowed or not? So we could either do yes, no, or we could do classification, it's part of this banned category. And as soon as these external models flag that, then we can do the same thing as we did with the input-output processing software filters and just say either we give a canned response or we ask for a different response or something like this, right? So these are all things that we can do. And this is, again, model-based, so we can train these. We can even add guardrails that we want. So in some of the popular guardrail software that I've seen, you can add guardrails, for example, where your competitor is never named. Don't know if that's great from a transparency point of view, but it's something that you could do. And you could train your own guardrails. You could say, actually, for my language, whatever your native language is, the language of your application, perhaps the guardrails, because they're often informed first and foremost by English language terms. It doesn't actually catch profanity in my language, or it doesn't catch toxicity or other nuances of my language. And I want to flag those things. These are all things you could train yourself. These algorithmic guardrails, they don't have to be large. They could also be much smaller. But it does require you to have machine learning people and machine learning infrastructure to train your own. And these algorithmic guardrails are often what you're kind of interacting with when you're playing around, trying to jailbreak or do something else with the model, and you're finding ways around it. It's usually not the most obvious route because that's usually trained and caught in these algorithmic guardrails, or might even be flagged already by the software filters. But you're a smart human and you can find ways around these things because it's just an algorithm, right? And I tried this early on with a few of the different large LLMs of how to build an ISMI catcher. That's like, if you don't know, it's a way to intercept mobile traffic, and it's illegal to do. So it's obviously also a huge privacy and security violation for anybody whose traffic you're intercepting. However, it is legal if you're a researcher using it in a lab for, to design new types of security attacks or privacy attacks or something like this. And so I was able to get past most of the algorithmic guardrails, actually all of the ones I tested. This was a few years ago now, by saying, like, don't worry, I'm a researcher. I have the ability to do this in my lab. I'm not going to do this in real life. So we can see that, and probably you've heard of a bunch of ways, smart ways to jailbreak. And it's a cat and mouse game. There's always a new type of jailbreak, and then it gets trained into the algorithmic guardrails and back and forth. So we can use these algorithmic guardrails, but we should also know that they're non-deterministic, and that also they can make mistakes. Then it's not like having a human, right? And I just want to show you some examples of some of these external algorithmic guardrails. There's an entire family of llama models that are under Purple Llama. You can look it up. And for example, the most recent ones, which is the Llama Guard 4, this is, for example, the different types of categories that you can flag. We see privacy is one of them. In my testing, give or take. If by privacy you mean, can it recognize if I'm directly saying, here's my phone number, can you repeat it? Yes. If by privacy in a more nuanced aspect, anything person related, or if I were to share something that you and I as humans would consider private, does it actually recognize anything of this nuance? No. Obviously, that's also not what it's for. And Llama Guard isn't the only one. There's also NVIDIA Nemo guardrails, and that also uses Microsoft Presidio from a privacy point of view, which attempts to find basically what I would call PII, or personally identifiable tokens, and then you can choose to redact them or replace them or pseudonymize them. So it does something. But it doesn't do, let's say, the nuance we've been talking about in this series related to things like reproducing training data and more advanced attack methods. So what else do we have? Well, we have a final category of guardrails, which looks at alignment, or what we would call alignment. Maybe you've heard of alignment already. And now we've moved from externally thinking about guardrails, or how do we rate input and output and decide whether it can go forward or not, and we've moved to the actual model itself. So now we're training the main model, and we're trying to train into it. How do we want kind of the responses, the content to look like? And this is obviously the most robust because you're actively training and changing the model itself of how you want the content to look, what you want to be able to reproduce. And if we actually did this at scale across many models, we could also avoid many of the attacks, because really the goal is we don't want the model to know how to build an ISMI catcher. Maybe we do, but perhaps maybe we don't for our specific use case or for our task, or we don't want it to produce profanity in our language, right, at all. So we don't want to have to pay extra to catch it. We want to just have a model that doesn't have that. Now, of course, it is difficult because models are trained on the internet, and the internet isn't always a friendly place. So what we have here, when we do alignment, or what I would call alignment or trained in guardrails, we have our normal steps of producing, let's say, a large-scale LLM. This could also apply for a multimodal sequence-based model, so video, audio, combined text and pictures and so forth, right? We have some pre-training step, and this pre-training is on a bunch of unstructured data. Hopefully we've partially cleaned it. Maybe we've deduplicated some of it, maybe not. And we're just doing this base, what I call base model training. So base language model training, or base audio model training, or base sequence-based model training, right? We could maybe generalize. Then we have this optional step, and is often called extended or sometimes continued pre-training. So this extended pre-training is, again, extended on, unstructured data. So sequence-based data that doesn't necessarily need to have labels or anything like this. And so this pre-training and this extended pre-training is producing basically just a model that can predict the next of whatever sequence it's supposed to predict, right? LLM, text, other stuff, mixed medium, right? And we might want to do extended pre-training. So there's some base language models that are released where you can then yourself do this extended pre-training. And if you're working in a language which most of the models don't support well, or in a particular context, let's say legal context or something like this, or specific types of audio, right? You need to collect audio from noisy environments, whatever it is. You might want to develop your own data set and do this extended pre-training so that it better matches the environment and the data you're trying to learn. And then there's the step that's called training. I would say we should better call this task-specific training, or even task-aligned fine-tuning, something like this, but we call it training, whatever. And this basically means we take a task like code completion, like chat completion, like instruction for agents or whatever it is. And from this base model, we train it to do more specifically what we're trying to use it for. So I describe my problem, you show me the code. Or I want to chat with you about this topic, tell me what you know. Whatever it is, right? And then at the end of that, there's often a step of alignment. Why does it come at the end? That's because we don't want the fine-tuning that we do there to potentially unlearn or redo any of the things that we're trying to do with alignment, which is specifically how do we align the model with whatever expected content we wanted to produce or not produce. And so alignment is often guardrails, or we might even call it human preference alignment, whatever it is. We're trying to make the model better, might want to make it friendlier, might want to make it funnier, but we might care about if it uses profanity or not, but this is all usually a part of some sort of final steps of fine-tuning. And this does require a note here. This requires you to have data so that you can do that. If you don't have data to do that, you're going to have to first collect data to do that, or label data, or create your own data. And this alignment is obviously, since it's built into the model, has more weight and decision power on how the model responds itself. The reason why you do it is because you want to try to avoid the amount of things that you have to catch with the other types of guardrails. So as a final suggestion, we can also start to think of new ways of designing things. So from a privacy perspective, we might want to say, okay, we don't think there's external algorithmic guardrails that protect us. We don't think there's input-output filtering that protects us. And we do not control the model development. We are using somebody else's model. Well, if you wanted to add essentially a pre-filtering mechanism on your side, you could try prompt rewriting, and you could even use something like an LLM as a judge. And for this, you might want to run your own LLM. You might want to decide, do you collect responses and start to train yourself? But essentially, you have some sort of user prompt. It can be an internal or external user, so either an employee, colleague, or an actual customer. You might use an LLM as judge design and have the LLM, or even have one of these guard models say, do we think that this has private information or confidential information from our organization? If we think it's clear to go, it can just go directly to the LLM. If we don't think it's clear to go, we can do things like sanitization, rewriting, so prompt rewriting, where we literally use that LLM or a combination of LLMs to create a synthetic prompt that approximates the prompt but is not actually the prompt, right? Give or take whether this actually controls privacy. You therefore need to have somebody actually looking at this and helping improve the system. Or you can start thinking through advanced privacy enhancing technologies, which you can read more about in my book. And then perhaps after this sanitization, rewriting, or pets, then it's clear to go to the LLM, right? So these are all options to you. To end up today, I'm going to give you a guesstimate. These are not real numbers. These are not supported by research other than my own knowledge and playing around. So take them as you will. If you are a researcher working on some of these things and you'd like to share some numbers in the comments or directly send them to me, I'd be very happy to look at them. Obviously, these are all based on more experience, and there are benchmarks on these things. One thing I would say about benchmarks around these types of attacks is the benchmarks are what we know so far about the attacks. They're not the amount of attacks that exist in reality, right? So let's do quick back of the napkin comparison. Input-based, so software-based, external algorithm-based versus fine-tuned. It's either fine-tuned using your own models or fine-tuned within the alignment step. So you really taking the time to think about what you want to protect. Curse words and insults, let's be real, input-based can catch a lot, so software-based. Algorithm-based can catch even more, and if you fine-tune it, you're probably going to catch most of this, right? We're just going to leave 99% because there's always going to be some new insults that the kids are using and you haven't learned it yet, right? Next one, copyrighted material, private information. Input-based, depending on if you actually decide to really build this out, you can probably catch half of them. Algorithm-based can get you further, but unless you're specifically building for your own task, for your own use case, what do you really mean here? And what is truly for you private information versus not? Because perhaps you actually need people to enter names, or you have a license to use particular copyrighted works from your own workplace, something like this. So there's quite a bit of nuance here. I think you can fine-tune quite a bit if you bother, but it is also expensive. So you have to make that decision. Malicious queries to your data, so data extraction attempts via either actual MIAs or data exfiltration types of attacks. Input-based isn't going to catch much. Algorithm-based also isn't going to catch much. And let's be real, even fine-tuned, you're going to have to spend and invest a lot of time. Doesn't mean it's not worth it. It, of course, is, but I'm trying to be realistic about what we can achieve. So if data is super private, you might just want to think not making it available, right? And then prompt extraction, data extraction attempts, I would put those estimates even lower for software and then about the same for the others. So I'm curious to hear from you. What security and privacy threat analysis, threat modeling, and testing do you do on your model and system deployment? I hope you've learned something about guardrails. I hope you've maybe taken some things that you might want to test out. And I'm curious for you to share kind of where you're at from thinking through this problem on your own systems. All right, until next time.